obviously something different. I've never tried this before. Today I'm going to do a short role play, and this video is just a test. If you like it, let me know, and I can make more teacher role plays in the future. And if you don't, then I won't, so no big deal. Anyway, this is just going to be a very short, very basic chemistry lesson. So today what we're going to be talking about is something called stoichiometry. And that sounds like kind of a long, confusing word, but it's really not a difficult concept to grasp at all. But let me be more general for a moment and just say that when we're talking about chemistry, we're talking about the study of change. Ignore my terrible handwriting. There we go. And in particular, when we say the study of change, what we mean is we're discussing changes in matter or changes in chemical compounds. So for instance, we might have two elements, hydrogen and oxygen, coming together to form a completely different compound, something new and something novel. And I think that when you look at chemistry this way, it's actually quite exciting. It probably sounds silly, but I find it so interesting that from these two different elements, when they exist by themselves, maybe they're not all that remarkable, but when they come together in just the right way, they form a completely different compound, something with new and novel properties. They form water, which, as you know, is essential for all life as we know it. And, I don't know, I just find that really interesting. So, to rephrase, when we talk about chemistry, we're talking about the study of change. And basically, that's all that stoichiometry is. We're discussing the mathematics of these changes. So we want to know, in particular, if we put in a certain amount of a reactant, how much product can we make? That's what we're doing when we're doing stoichiometry. So let's talk a bit more specifically about stoichiometry. Okay, one thing that you have to understand before you can do stoichiometry is something called dimensional analysis. And dimensional analysis is really just converting from one set of units to another. Okay? So, let's say that we know there's a person who can run 100 meters in 10 seconds. Okay, but we want to know what their average speed is in miles per hour. So what we're going to have to do is we're going to have to convert meters into miles and seconds into hours, right? And so what we need to do this is we need something called a conversion factor. Okay, and that's just a conversion factor. It's just going to tell us it's a very basic fact. It's going to tell us how many meters are in a mile, or how many seconds are in an hour. So let's see here. Why don't we start with meters? Let's say, let's start with some conversion factors. Let's say we know that for every 1,000 meters, we have 1 kilometer. And for every kilometer, in 1.609 kilometers, 1.6 kilometers is 1 mile. Okay? And we'll need one more conversion factor. We need to know that there are 3,600 seconds in 1 hour. Okay. So we're going to use these conversion factors to solve this problem. And when we're setting up a dimensional analysis question, it's very simple. All you have to do is stack up the units that you want to cancel one on top of the other. So we know we want to get rid of meters. So all we have to do is find our conversion factor as meters. And we know that there are 1,000 meters goes on bottom, right? Because we know that if we divide meters by meters, it's going to cancel out. We're going to be left with just 1. The numeral 1. Right? Okay, so all we have to do to cancel out meters is stack them on top of the other. And then, of course, what goes on top is kilometers. Okay? But we don't want kilometers in our final answer. We wanted to go from meters to miles. So it turns out we're going to have to use another conversion factor. And of course, we want to get rid of kilometers. That goes on bottom. We want to end up with miles. So miles goes on top. So in 1 mile, we have 1.6 kilometers. We're not going to worry about being too exact, so that's fine. We don't have to write out the entire thing. Okay, and so that, as we can see, meters is going to cancel. Kilometers cancel. And that's going to just leave us with miles on top. But we're not finished if we stop here, we're going to have a number with units of miles per second, and that's not what we want. We want miles per hour. So we have to use our final conversion factor. 3,600 seconds, right? In 1 hour. And when we seconds cancels out, right? We solve this, we will see we end up with a number that's about 22.4 miles per hour. Okay? That's our final answer, and that's all we're doing with dimensional analysis. We're converting, units from just one thing to another. Meters into kilometers or miles and seconds into hours, weeks, days, years, whatever. It doesn't matter. If you have, any unit of distance can be converted into any other unit as long as you have a conversion factor. Just like any unit of time can be converted into another unit of time. So, get rid of this, and essentially, all we're doing with your stoichiometry problems, it's just a dimensional analysis problem. Except we're converting from one type of reactant into another kind of product. So let's see if I can find an example here. I'm actually going to cut my lesson off here. I know it's short and we didn't actually get into much stoichiometry, but it's getting a little bit late for me. And I really didn't mean for this to be a short test video, so I'll wrap it up now. And if you would, just let me know what you think, and if you'd like to see more topics like this. I really was planning on talking about anything in the general sciences, and my goal would be to make it not only relaxing but informative for anyone who wants to learn. And I will be honest and say that part of my motivation for doing this is that I'm studying for my MCAT exam, which I have coming up in June, actually. So, not only would I be relaxing, but it would also be an opportunity for me to, kind of refresh my memory concerning these topics. But along that same line, I am not an expert by any means. I'm still just another student, so if I make any mistakes or anything, feel free to, kindly bring that to my attention, because I would hate to spread misinformation or anything like that. So anyway, thank you for watching, everybody, and I hope that you liked this video. And if you did, just leave me a comment and any suggestions that you might have. I really appreciate it, and I'll see you soon.